All right, so let's go and take a look. We'll go ahead and move on to non-sterile reconstitution practice, a worksheet. Before we jump into the questions that we really want to get into, namely 7 and up, we'll go ahead and do a few practice ones. So with non-sterile reconstitution, we're looking at just finding a specific strength. So this one's just a little bit easier. In the past, we used DHQ, right? Desired over half times quantity, or per quantity, or quantity per equals X, our amount of solute. Here, it gets watered down just a little bit. For these, we'll be doing D times Q equals X, which is the same. D times quantity, D is desired strength, X equals amount of solute. Let's see what that looks like. So we've got number 1. They're telling us they want 500 milliliters. They want 500 milliliters of 1/4 strength hydrogen peroxide solution for wound irrigation. Here, we're going to assume it's just 100% of hydrogen peroxide solution strength, okay? Unless told otherwise, that's what we're going with. And they want 500 milliliters. So our desired is the 1/4 strength, okay? 1/4 strength times our Q, in this case it's the quantity, 500 milliliters, and that'll give us our X. 1/4 times 500. In my calculator, I could do 1/4 times 500. Gives me 125 milliliters. I could also do something along the lines of 500 divided by 4, right? If I just multiply across, I've got 1 times 500 all over 4. 500 divided by 4 still gives me my 125 milliliters. Now, these questions are 2 parts, okay? The first part is the 125 milliliters, okay? Now they're asking for the sterile water. If you do have a solution that you're making using a solvent, you've got 500 milliliters total. And they're saying 125 comes from the hydrogen peroxide. The last part is establishing how much sterile water, because you still have to find that difference. And so this is 1A. We could call this 1A. And so we've got 1B. That looks like a 6. 1B, you've got 500 milliliters minus 125 milliliters. And that'll give us our 375 milliliters. And so the way we look at this, it's going to be the total amount minus our solute amount. Or you can even call this the amount of the concentration amount that we're using. Would give us our solvent amount or diluent amount that we have to add to cover that remainder. So that's number 1. In this video, I'll also include number 2. If you're okay with number 1, you could just skip number 2. Number 2, we have, like the second problem, we'll do number 4. So they say 1 quart of 1/4 strength stock acetic acid solution. So what that looks like for us is, well, first thing we want to do is do a conversion. We want to look at what we're starting off with. Always look at what we're starting off with and what we're ending with. We're starting off with 1 quart, and we're looking at answers in ounces. So we know we have to convert. We'll go ahead and convert from quarts to ounces. We know that 1 quart equals how many ounces? Okay, 32, that's right. Look at that. So 1 quart equals 32 ounces. So doing dqx, we've got the desired amount is, I'll go ahead and insert my my converted unit. And if you want to do the math on this, this one doesn't really have a lot of math to go with. We've got 1 quart equals 32 fluid ounces. This one's just straight off the metric sheet, so you wouldn't be able to do anything crazy with it. So we've got 32 ounces. Oh, I'm so sorry. No, that's not right. Sorry. Our D is our desired, so that's our strength. We've got 1/4. 1/4. Whew, what a catch. 1/4 times our quantity amount, which is 32, equals our x. 32 divided by 8, or I'm sorry, 32 divided by 4 gives us our quantity of 8. So 8 ounces would be our amount of acetic acid solution we want to use. So we've got 8 ounces, and that leaves our remainder. We knew we were starting off with 32 ounces. So 32 ounces minus our 8 gives us our 24 ounces of sterile water. That's what that looks like.